Hello everybody, so today I will talk about this question. Maximum XOR of two numbers in an array. So even though this is a medium question, this is very tough. Okay, so giving an integer array nums returns the maximum result of nums I XOR nums j, where 0 to I to j to n. Okay, so I can find that I can be equal to j, so it is possible that I choose two same number. The same number twice, but in that case, XOR becomes 0. I don't know if it's a good way of choosing two numbers, but 0 is possible. Yeah, anyway, so in this question, I'm giving an integer array nums, and I will return the maximum result of XOR, so I should return actually integer. Yep. Okay, so let me show you an example first. So when I think of the bit array, firstly, let's convert each number into a bit array. So I will write it in a least significant digit first order. Actually, this is a bit wrong, so I remove this 5. Okay, so first 3. This is 1 and 1. And for 10, there should be 0, 1, 0, 1. And for 5, there should be 1, 0, 1. And for 8, no, 2, there should be, okay, let's remove 2. I think this is enough. So for 8, this should be 0, 0, 0, 1. Yeah, so this is, I've converted each number to bit array. Yeah, so from here, I will take XOR. So for example, if I choose 3 and 10, the XOR becomes 1, 0, 0, 1. Yeah, so there should be 1, 8, so 9. Okay, and if I take, let's say, 3 and 5, it should be 0, 1, and 1, 0. So it should be 6. Blah, blah, blah. So in this way, I can take the XOR of two numbers. So obviously, the brute force approach is that I take every possible pair and calculate the XOR, and I return the maximum one. Yeah, but it takes n, assuming that there are n numbers in the given array. So there are all n squared pair of two numbers, and for each I have to traverse the bit array towards the end. So let's assume the length of the bit array is L. In that case, it takes n squared times L. Okay, so what is this L? Actually, this L is the longest length of the bit array. So I can think of this as the length of the bit array of the maximum number. Because obviously, as the number becomes larger, the bit array becomes longer. So I can think of this L as the length of the bit array of the biggest number. So this is the brute force approach. But I have to optimize this because of this constraint. I can find that length of the array nums is up to 2 times 10 to the 5. So n squared is not allowed. accepted. So I have to optimize this. Okay, so I'd like to optimize this time complexity. And which part should I optimize? So n is up to 2 times 10 to the 5, which is so large. But how long is L at max? So as I said, L is the length of the bit array of the biggest number in the given array nums. And the biggest number is 2 times 10 to the 5. So, no, sorry, 2 to the 31 minus 1. So how is this bit array look like? Actually, this looks like this. There's 31 digits in this bit array. So what I can tell from here is L can be up to 31, which is very small compared with n squared or n. So when I say I'd like to optimize the time complexity, I try to optimize this part, n squared, to maybe n log n or over n. And I don't, make effort to optimize this L part. Okay, so that being said, how can I optimize this n squared part? So let's take a look at this one again. So I'd like to calculate the XOR of this and this. Yeah, let's put 0 here and here. Okay. So when I think of this, I noticed something very important. So the thing is, let's say I have an array which looks like this. 0, 0, 0, 1. So, sorry. This is the most significant digit. So 1, 2, 4, 8. And I have this number, 0, 0, 0, 1. And I have two candidates of the pair of this number. So the first candidate is 1, 1, 1, 1. The second candidate is 0, 0, 0, 0. So which is a better partner for this guy? Yeah. So firstly, you take a look at the most significant digit. So for this, for the most significant digit part, I can say this one is a better partner because I can get 8 with XOR of this position. But with this, XOR becomes 0. I can say here I get 0, but here I get 8. Yeah. And the interesting thing is that for other digit, for the, less significant digit, this 111 is better for this guy, 0, 0, 0, because I can earn 1 and 2 and 8, which is 7. But on the other hand, for this guy, 0, 0, 0, they can get 0, because all of them are the same. So I can say for this part, I can earn 7. Looks good, but for this part, this can earn 0. For this part, it can make 0, but for the most significant digit, I can get 8. And the observation is that how well I do in the least significant digit, I cannot, compensate or let me rephrase. So I should focus on getting XOR 1. What should I say? Okay, so I should make every effort to make the most significant digit different, like this and this. Yeah. And if they are different, I can say no matter how other guy like this do well, if the most significant digit are the same and XOR is 0 for this position, he cannot beat this guy whose most significant digit XOR is 1. Yeah. Hope you understand what I'm saying. So the observation is that I should take a look at this most significant digit first. And here, for this guy, I can immediately say this isn't a good option because this is 0. If I take 1, maybe this or this, no matter how this one does well in the less significant digit, it cannot beat this or this. So this is not the option anymore. Yeah. So that's what I can say from this observation. Okay, so now let's think how we can do it. So when I take a look at this, I hope that I can create 1 here, XOR 1 here. So I try to create this one. And here, I try to check every possible combination of XOR and think if it is XOR or not. And check I could create 1 in the end by taking a look at every possible pair. But this takes n squared time because, I mean, theoretically what I'm doing is the same as the brute force approach, taking a look at every possible pair. So instead of that, I use the HashSet. So it looks just like the two-sum up question. So when I take a look at this 0, I remember that I saw 0. And then I take a look at 1, and 1's pair is 0. If 0 is somewhere, I can say, oh, I could create XOR 1. So yeah, that's how we can check it. And let's say if I can't find XOR yet, I register this number to the HashSet and continue. And every time I find a new number, I check if I can find the pair in the number before I saw before. And if I find the partner, which makes the XOR 1, that's it. But otherwise, I continue. So I can say scene, update scene, and keep going till I find XOR 1. Yeah. So as I said, by the way, how can I find this XOR 1? So as I said, if I have the number like this, and if I try to create 11, I can think of this way. This number is 10 XOR 11, which is 0, 1. And I can confirm that 10 and 0, 1, I mean XOR of them is 11. So actually this is a quite, basic formula of XOR operation. So you can check it everywhere on the internet. But yeah, that's something I can do to check in the for loop. Okay. So this is something I can do here. And here, as I said, I can find the 1 with 0 and 1. Yes. So at least I can say for this position, I can find XOR 1. So let's take a look at most significant 2-digit. So here, I hope I can create 1, 1. So this one came from this one. I could create one. Okay. So I hope I can create one and take a look at this. And I do the same method here. So I do the for loop with HashSet. And the thing is, firstly, I find 0, put it into the HashSet, and 0, 1's XOR is 1, 0. So hope I have 1, 0 in the HashSet, but no. So I register 0, 1 to the HashSet. Now HashSet has 0, 0, and 0, 1. And now I got 1, 0. So the partner should be 0, 1. And I can actually find the 0, 1 in the HashSet. I could find it. So this means that I can create 1, 1. So I can say, yes, I could create 1, 1. Yeah. So that's good. So next, I keep going. I take a look at these 3 digits. And here, I hope I can create 1, 1, 1. So in this case, this one came from this 1, 1. Yeah. So I do the same method again. So I omit the process, but sure I can find 1, 1, 1 here and here. Oh, let me change the number a little bit. Let's say this is 0. If I do this, I can say I cannot find 1, 1, 1, right? Yeah, I can't. So no, I couldn't. So the best here is 0, 1, 1. Yeah. So as I said, I definitely have to keep this 1, 1 because even if the XOR becomes 1 here in this digit, that doesn't compensate these parts missing XOR. And firstly, I try to make this part, I mean this position XOR to be 1, but it doesn't work. So I just put 0 here. Yeah. I shouldn't make it this 1. I shouldn't try to make this 1 with the cost of making this or this to be 0. Yeah. So I can say the best here, I mean, last 3 digit position is 0, 1, 1. And I keep going. Here, I hope I can create 1, 0, 1, 1. And I try to take a look. And actually, yep, I can create it, this and this. So I do the HashSet with, for loop with HashSet approach again. And yes, I can create 1, 0, 1, 1. Good. So the answer should be this 1, 0, 1, 1, which is, I don't know, 1, 4, 8. So returns 13. Okay, so this is the basic approach. Okay, so now you might think, why don't take a look at each digit in each step? So far, I've checked firstly this suffix, then this suffix, this one, then this suffix, then this suffix. Why don't I check one digit by one digit? Yeah, digit by digit, I mean. So let me show you why with this example. Let's say I start from here and I try to create 1, obviously, XOR 1. And I can find create X1 with this and this or this and this. And at this moment, choosing this and this is not an option anymore. Because if I take this and this, XOR becomes 0. So I can say choosing 0 and 1. I mean, so here I can say and 0 and 1 or and 1 and 2. These are the only possible options. And let's take a look at this. Yeah, I'd like to choose N0 and N2 or N1 and N2. But at this moment, N0 and N2 is not the option anymore. So I have to choose N1 and N2. So this is why I used suffix in each step. If I take only this digit, I feel that I can use N0 and N2, but it's not allowed anymore because in the most significant digit, if I chose N2 and N0 and N2, XOR was 0. So it's not good. The same thing happens here. If I take a look at only this digit, it seems like N0 and N2 is a good option, and N1 and N2, also this is good, but N0 and N1, this is not a good option. So yeah, this means that I should, oh, let me change the number here, sorry. Let's think. Yeah, let's think of this case, sorry. So if this is true, I can say this and this, I mean N0 and N1 or N0 and N2, they look to be a good pair. But I cannot choose them. I have to choose N1 and N2. So even though here N1 and N2 pair, I mean XOR of this and this is 0, I have to choose it because of the constraint I made before. So I hope you understand what I mean by this. So this is why every time in each step, I took a look at the suffix to create the best possible XOR value. Okay, so now I start the implementation. So I delete this. Yeah, I delete this. Actually, this is the, yep. I copy this here. So let me sort out. For each suffix, I mean, I keep track of the best, last best. And here, try to create last best. I mean, shift by one digit and take OR with digit 1. So I mean, if the last best was 1, 0, I shift it once like this. Then take OR with 1, so 1 comes here. Oh, sorry, because it's a bit confusing because I wrote it in a least significant digit first way, but actually this, assuming that I shift a digit in a leftward with most significant digit first manner. So anyway, what I'm basically trying to do is if I have 1, 0, the most significant digit first, most significant digit last, like this. So in this word, let's say the last best was 1, 0. In that case, I try to create 1, 1, 0. So that what I'm doing here. Okay. Then if check with HashSet, like this, and now I check if I can find the, try to create, let's say, candidate. Yep. So if I could create it, I can say last best should be best candidate. Yeah. And otherwise, last best is just this one. So here I said if the last best was 1,0, I try to create 1,0,1. But if I can't create 1,0,1, I just put 0 here. So this 1,0 from the last best is still here, but I put 0 as the least significant digit. Okay, so this is the basic, logic I will implement from now. Okay, so I create the implementation. So the first thing I should do is create bit arrays. So okay, now I have the arrays, and now let's say it looks like this: 1, 0, and just 1. So this least significant digit first, most significant digit later. Yeah. So if I have 1, 0, and 1, definitely I have to put 0 here when I use this approach. So I have to fill in zeros so that each bit array, every bit array has the same ranks. So max ranks of the array is so I can say length of the bit array of the biggest number. So it looks like this. So I have to fill zeros on these arrays, shorter bit arrays. So get in this way. So now I've done with the preparation. So now bit array is created with with each array has the same ranks. Okay. So from here, I work on this. So last best should be 0 first. Let me say last max. Okay. So I traverse from the last digit. So in a reversed order. And so here, I take a look at this, and I try to create, as I said, this one. So max candidate is, yeah, let me rename this. Okay. Something like this. Wait, is this correct? Last max. I'm a bit confused. If I do this last max is multiplied by 2, correct? Yeah, I think this is correct. Let me check. Yep, I was correct. So with this, last max is actually divided by 2. Okay, so I create the max candidate, and here I will try to create max candidate. I can say so. Here I can say I find the number which looks like this. So arrays from index j. No, sorry. Arrays index j. So this is a single bit array. And because currently I'm at index I, so I can say I or later. So here, this is a bit array. And now I try to create the number from here. So I create the suffix num here. So I can say expected num, or I should say wanted num, is suffix num XOR max candidate. As I said here, like this. I tried to create a candidate. And if I try to create a candidate with XOR, the pair of the current number should be current number XOR candidate. As I said somewhere, but deleted. Yeah. So this is the wanted num. So if the nums, if this is already here, I can say I've found it. So let's say found max candidate flag initiate with false, and this should be true, and I should break. Otherwise, I keep searching, but I have to append this suffix num to scene nums. Okay, so this is it. Let's rename this to scene suffix nums. Typo. Okay, so this is it. Now I keep going, and here, here, as I said, I do this. If I could create, where is it? If I could create the max candidate, then last max should be the candidate. Otherwise, last max should be, as I said here. Okay, this is it. Now, in the end, after traversing, after checking every possible suffix, I've checked the whole, bit array, pair bit array. The pair of the bit array, which is the whole length. So last max is exactly the one I'm looking for. Okay, this is it. So I quickly implement this and this helper methods. So okay, so I can do it and I can return it. I don't explain this because this is, quite basic. You can ask it in ChatGPT. And if I try to implement toNum method, so the first, index, let's say I have 110, 101, sorry. The first digit is equivalent to 1, then 2, then 4. So I can say array index I, this number, I have to multiply with 2 to the I. Yeah. This is to the 0 to the 1. So I, increment read by this digit equivalent number, and I return read in the end. Okay. So now let me submit. Two-bit array. A typo. Since suffix nums, oh, this is broken. Yeah, type again. Typo. Okay, so it doesn't work. Let me check. Okay, so first thing I should do is definitely check if the bit array is created as expected. No, I should see arrays. Wait, I should see arrays here. So 3, yep, 1, 1, yes. Okay, seems like the bit array is created as expected now. So okay, so next thing I should do is every time I see how the last max is, it's always 0, even after the first iteration. Why is it? So, oh wait, here, this should be within this for loop. Okay, now accepted. So let me comment out the print statement and let me submit. Good, accepted, great. Okay, so for this approach, the time complexity should be O of NL, let me tell you why. So firstly, I checked, this ranks 1, and I do the for loop here. So it take 1 times n. Then I took a look at the suffix ranks 2. I checked this and then this and this and this. So it takes 2 times n. Then I took a look at 3, suffix ranks 3, and I do this for loop for each number. So it took 3 times n. So in total, because this is 1 times L plus, 1 times N, 2 times N, blah, 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 times L times N. So in total, there should be, yeah, I write it so, yeah. So I will explain, yeah, in detail. So in total, the sum of 1 till L is L times L plus 1 divided by 2 times N. So this should be, L squared times N. It was good that I explained, in detail because I've noticed my mistake. So the time complexity is O of N times L squared. Good. Okay, so for space complexity, the only data structure which is non-constant is, the list of bit array, this one. So obviously this takes O of N times L because each bit array has the ranks L and there are N arrays. So it should be O of N times L. So this is the space complexity. Good. Okay, so let me quickly wrap up. So today I said the question, maximum XOR of two numbers in an array. In this question, I'm giving an integer and nums, and I return the maximum result of XOR for every possible pair of two numbers. And in my optimized approach, the first thing I did was to create the bit array from each number. And then I have the list of bit arrays. And then, by the way, this bit array, each bit array is, least significant digit first. And then I took a look at the shortest suffix, which is ranks 1, and I tried to create XOR 1. And if I could create XOR 1, yes, it's good. I can say for this position, for the best XOR value of the best pair, XOR value of here is 1. But if I cannot find one at this position, it should be 0. Then I take a look at the suffix ranks 2. And the interesting here is that I inherit the result of the previous result. So if I could find 1 here, I try to create 1, 1. But if I couldn't find 1 and the best is 0, I try to create 1, 0 here in the next suffix. And I continue it until the suffix is exactly the ranks of the, bit array of the biggest number in the given array nums. And at that moment, the calculated best XOR result is exactly something I should return. So yep, I can return it. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.